My name is Brian Keller. I'm a technical evangelist for Visual Studio Application Lifecycle Management, and we'll talk about what that means. How many people were able to come to yesterday's session that I was in? Okay, great. Thanks for coming back. So for those of you that don't know me, I work at Microsoft Corporate, so it's my second TechDays Belgium, and it's a pleasure to be here. I have worked on Visual Studio in one form or another for the last 9 years or so. So I started off on J# and have worked on XNA and worked on our Visual Studio Express products back when we were launching those. And for the past 3 years or so, I've been working exclusively on our application lifecycle management technologies, and I absolutely love it. I'm on Channel 9 every week, and I also maintain a blog. The blog that I maintain, for those of you that weren't in my session yesterday, I put pretty much all of my demos, all of my slide decks, links to session recordings online, so you can even go home and download a virtual machine and actually play with the same demos that I'll be showing you here today, which is a really nice way to become hands-on familiar with what we're talking about. And also you can turn around and show that to your colleagues and user groups and things like that. So I try to make sure that that's all available for you so that you can just easily get started and continue the evaluation process long after Tech Days. I've worked on 2 books. I'm not trying to sell my books. I really don't make very much money from them at all, but a lot of people ask about resources to get started with application lifecycle management. And so I worked on the first book to kind of be the breadth end-to-end view. It's kind of a 200, 300 level book that dives into the different features that light up for different roles on the team. So whether or not you're an architect or a tester or a team foundation server administrator, that kind of gives you the end-to-end overview of what we do with application lifecycle management in this release. And then the TFS book is really designed for the person who's in charge with setting up the team foundation server instance, or people that might be doing something of a more advanced branching and merging strategy, or trying to figure out how to get testing working with TFS. So both of those are now available. So what do we mean by application lifecycle management? You know, it's kind of this funny term. We used to call ourselves Visual Studio Team System, and now we've called ourselves Application Lifecycle Management Capabilities of Visual Studio 2010, which is really fun to try to explain to my mom, who has no idea what I'm talking about. But in a nutshell, it really means that we are helping teams, so all of you, go out and work better together to build great software. And really working better together is the key out of all of this. I was in England last year, and I noticed that on their 20-pound note, they had a picture of Adam Smith. And Adam Smith is credited with a lot of things as it relates to economics, but the quote that was actually on this 20-pound note struck me. I didn't realize actually that he had invented or was credited with recognizing the efficiencies that you can have when you have division of labor. And specifically, this is talking about pin manufacturing, but we are all familiar, of course, with how division of labor really helped spur the Industrial Revolution, and we have different people on a team who each specialize in their given piece of assembling a car or assembling a bicycle, right? And so you could get really, really good at building the handlebars, and I could get really, really good at building the tires for a bicycle, and he could get really, really good at assembling the frame. And assuming that we're all doing our job as we should, we can take all those pieces together and apply them together, and at the end, we've got a bicycle, right? That works really well in industrial manufacturing. And to a degree, it's the same thing that we've done with software development. You know, if we asked how many people in the room are web developers, I'm sure we'd have about half the hands go up. And then if we started to break it down from there, we'd find out that really we're not all the same type of web developer. You know, one of us might specialize in writing the back-end code to talk to the database, and somebody else might be a front-end designer, and somebody else might just spend their entire job tweaking style sheets and trying to make everything look really nice from the front end. So there's different specializations within those broad categories of specializations, and that's great. That means that you can be really, really good at style sheets, and I never have to become an expert in that, and we can come together and build great software. The challenge with that, of course, is that building a bicycle is not like building a website. There's a lot of information that needs to be exchanged in order for us to understand what it is that we're building. If I said, hey, you know, I'm going to start a company and I'm going to sell widgets and I'm going to build a website, and we asked everyone in this room what that website should look like, we'd probably get 100 different answers. And so bringing the team together and trying to make sure that, number one, we have clear defined goals. We all understand what the requirements of the business or what the requirements of the customer are. That's a key part of making sure that we can build great software. And also helping the individual roles on the team to communicate and to collaborate throughout the course of that process is also critically important. We can't just assume that he's going to build the tire and I'm going to build the bike frame and it's all going to come together at the end of the day. We really have to communicate. And so our job at Microsoft in the developer division, as we look at this problem space, is we're constantly evaluating the different roles that are involved within a software development lifecycle. And we're trying to figure out how we can eliminate waste. How can we eliminate confusion? And how can we reduce the amount of effort and the amount of potential for problems that exist as you hand off work from one person to another on a team. And so that's really what we've tried to do with the application lifecycle management technologies we have. If you're familiar with what we did in Visual Studio Team System around 2005 and 2008, we brought a few roles together. We allowed the developers to work better together with source control. We gave some project management capabilities that you could start planning your work and start decomposing and breaking that down. We also introduced this database professional product that you'll be hearing about later on this afternoon, which is really focused on helping you to bring the database administrator and the database developer back into that role. And we had a couple of offerings around the architecture product. In 2010, our big new role that we've brought into the rest of the lifecycle has been focused on the manual tester. So how often do you have manual testers that kind of sit off in their own world and they work against their own system, and you occasionally talk to them when you need to figure out what it is that they just filed against you in terms of a bug, but for the most part they go off and do their own thing and you do your own thing, and rarely do you talk to one another. And so we recognized that disconnect both within Microsoft and within the industry, a lot of the customers I work with, and we wanted to bring them under one roof and allow them to communicate back with Team Foundation Server, which is really the heart of our application lifecycle management solution. Now, that's not to say that we only address testers in this release. We also made a lot of improvements to our architecture tooling. We made a lot of improvements to the way that we do version control and branching and merging and project management, and some things that I'll show you here as well. But if you kind of look at what we delivered in this release, we're always trying to bring more roles together and focus on where the biggest waste is in the system that we can go eliminate and eventually help you eliminate as well within your own teams. So I've mentioned Team Foundation Server. How many people are using Team Foundation Server today? Great, fair number of you. If you're not already using Team Foundation Server, then let me just give you a deep background here on kind of what it's meant to do. And even if you are, I find that a lot of people are just using Team Foundation Server for basic source control, maybe some work items. And so a lot of people, when I start talking to them about the capabilities that exist in the product, they're not even scratching the surface in terms of using what they actually own. So hopefully after today, after this presentation and some of the other ones that are happening today, you'll realize that you actually own a lot of capabilities that you may not even be aware of. So Team Foundation Server, it was built from the ground up to really not just be a great source control solution, not just be a great bug tracking solution, but to really bring together all the different facets of your application lifecycle together into one system. And by doing that, we can then start to draw some comparisons and start looking at some reports and start making decisions about what's happening over here and how it might be impacted by something that's happening over here. So for example, we have both source control and work items built into the same relational database. And by having both your work items, which could be a bug, a requirement, a task, and that source control in the same location, it allows me to start linking the two together and start drawing some conclusions. For example, by saying, okay, I know that this file was checked in on such and such a date because it was meant to fix this bug over here. And by the same token, I can query on this bug and say, hey, when was this bug actually fixed? In what branches of my source control is it fixed? And did that fix go out to the customer already? And so those are the types of things that you can start lighting up. And as we add more and more artifacts like test cases that came in the last release or in the 2010 release, then you can start to draw even more comparisons, and you can say, okay, I've implemented this software over here. I know that my developers have checked in the code, but how have we tested it? Can we actually prove that it's working? And how's my test plan progressing? And for last night's build, how did those tests actually go? And so you'll see later on, I'll show you some of my favorite reports that light up within Team Foundation Server as you start taking advantage of that. So there will be some things that I'll show you today that don't require Team Foundation Server. And in fact, some of the things that I'll be showing you, you could use just as easily with Git or Subversion. But for the most part, Team Foundation Server is the heart of our application lifecycle management solution. So the majority of the things that I show you will assume that you're at least using that in some capacity. Now, for those of you that may have in the past been tasked with installing Team Foundation Server in previous releases, I apologize. It kind of has a really bad rap for being a difficult product to install. And the reality is that in the first release in 2005 and 2008, we didn't assign a lot of resources to try to make the setup experience really easy to work with. But in 2010, we really wanted to make sure that everybody in the world that wanted to could easily get going with Team Foundation Server and could easily install that. And so to prove that, I would love to see, again, the reverse of what I asked earlier. Who's not using Team Foundation Server? Okay, and out of those hands, I would love to get a volunteer to come out and help me for just a quick demo here. Not everybody at once. All right, thank you very much. Round of applause for our volunteer. What's your name?
Michelle.
Michelle. Nice to meet you. Thanks for coming up. So what I'm going to have you do, and we've never met before, right? No. Okay, great. So what I'm going to have you do is actually install Team Foundation Server 2010. Now, in a past release, we would have been here all weekend. Of course, we only have a few minutes here this morning. So you've never installed Team Foundation Server before, right?
No, I didn't.
Okay, fantastic. So you're a perfect candidate. What I have right here is actually Team Foundation Server after I've already done the first phase of the installation. So really, I just opened up the media, I inserted it, I ran setup, and it copied the installation files to my disk. So now I'd like you to take over and go ahead and jump on the mouse here. And you're going to click on Configure. And so at this point, we're going to give Michelle some very nice wizards here that we hope can actually take him quickly through the experience of setting up Team Foundation Server 2010. And in 2010, we introduced a new configuration called the basic configuration, which you see right here. Now, basic configuration is really nice because you can set this up on even a client workstation like I have here. I have a Windows 7 machine that we're working with. You can use SQL Server Express if you want to. And it gives you source control, work item tracking, and test case management. Now, what you don't get with this configuration is our SharePoint integration or our reporting configuration, but you can always upgrade later and add those capabilities over time. So I'm going to turn it over to you, and you can show us how to install Team Foundation Server. Keep in mind, he's never done this before, so we'll see how it goes. All right, you passed the first step.
You have SQL installed?
We do have SQL installed, so you can take advantage of that.
Okay, that's fine for me.
Yep, he's getting the hang of it. Next.
Should I read everything?
Sure. And so now what it's doing is it's going out and it's checking my system configuration to make sure that it's all set up with the necessary prerequisites. Again, if you've done this in former releases, we kind of allowed you to get pretty far down the installation experience before you realized that maybe you were missing something as part of that release. And so now it's telling him that yes, the machine is ready. And so if we're ready to move ahead, we can go ahead and click on Configure. Sorry, I shouldn't be telling you what to do. I might click on Configure. And now this is it. So now it's going through and it's actually configuring my system with Team Foundation Server 2010. Another thing to point out while we're doing this is that if you have Visual Studio 2010 with an MSDN subscription, you actually already own a license to Team Foundation Server 2010. So you can go to your MSDN subscription, you can download that. We also give you a license of SQL Server 2008 Standard Edition that you can use if you wanted to set this up with a proper version of SQL as opposed to SQL Express. And now you're pretty much off and running. So this will go ahead and install and configure. And once we get done with this, we'll have our own Team Foundation Server instance ready to use that we can work with today. So that's it. Thanks so much for taking the time. All right. And just in the interest of time, I think there's probably another 90 seconds on there. So there you saw how you can set up Team Foundation Server 2010 in about 5 minutes. In the next release, you may have seen at the PDC that we announced we are making Team Foundation Server available as a Windows Azure service as well. And so that's something that we're hard at work at. In the future, you'll be able to set up Team Foundation Server for yourself in the cloud in about 20 seconds. So it's a really, really nice experience there. I've been playing with some early builds, and I'm quite excited about what we have going there. So we showed how he can set up Team Foundation Server back when he gets to his office on a Windows 7 client if he wants to. Obviously, that's going to work really well for small teams, but if you have a much larger team, I just want to show you the other side of the equation, which is how Team Foundation Server scales. This is our dev instance at Microsoft. So this is the instance of Team Foundation Server that we use internally to go out and build Visual Studio and Team Foundation Server 2010 and Expression. So there's a few thousand people that actually work against this machine. You can see 17.3 terabytes of data. So it scales quite well. If you have a project larger than this, I would love to see it. Here's another example of just the breadth of all the different teams at Microsoft that are using Team Foundation Server. So this is in addition to the developer division. We actually have set this up as an enterprise-wide service. So I can go to a SharePoint site if I want to and request a new project gets created for me. And then within 48 hours, I'll have a brand new project that's managed by our IT team that I can use to store all of my source control and work items. And it's really nice having that multi-tenant solution available for me. This just shows where in the world, there's actually a few X's missing here as well, but these are the major places that we use Team Foundation Server 2010 across the company. The thing to point out here is that our servers are, for the most part, all hosted within Redmond. So despite the fact that we have high latency coming from Australia and from some of these other parts of the world, we actually have very good results using Team Foundation Server. And we have a proxy server that you can set up, which becomes a look-aside cache. So if you have remote offices, I would strongly consider you set up a proxy because that will actually help your bandwidth coming across the wire, because the first time you get the file, it becomes cached, and then everyone else in your remote branch or even you locally, when you go to perform a get again, that data is already there. And because everybody that has an MSDN subscription gets their own license to Team Foundation Server 2010, you should have, if you have a team of 30 people, that gives you 30 server licenses, and you should have no problem allocating a few of those to proxy servers if you want to. So this is our basic configuration that we just set up here on stage, which basically gives you, source control, work item tracking, and all of those capabilities on a single box. If you wanted to scale this up, you have a few options for doing that. One is you can actually piece apart the data tier and put that on another machine and have the application tier front end that. That's usually only required if you get into several hundred users. I could actually support a few hundred users off of a single Windows Server box without needing to scale that up. And then as you start looking at larger organizations, you may want to take advantage of the new network load balancing capability that we have. So you can actually set up multiple application tiers which service all of the client requests that are coming in. And then that way, if one of those needs to be taken offline or accidentally fails over, then you have plenty of other redundancy in the system to service that. We also have what's called a team project collection that we've introduced in 2010. So this is a nice way to actually segregate the different projects that you use. And when you use a team project collection, all of your team projects get stored as a single database. And that means that you can move it from one Team Foundation server to another. It also means you can upgrade it independently on a different schedule than the rest of the team projects. The really nice scenario here is if any of you are consultants and you work on team projects that you want to then hand off to your client at the end of the project, I would recommend taking a look at team project collections for that, because then you could just export it from your team foundation server, hand it off to the client, and then at the end of that project, they can own and maintain that, including all of the history that's associated with it. So it's really nice for being able to support that model. And then, of course, you can scale out lots of different components as well. So we have a SharePoint scale out because you can set up SharePoint alongside Team Foundation Server. I mentioned the proxy instances you can set up in remote branches. So there's just really lots of different architectures you can take advantage of. So now let me drop into a couple of other demos, and I'm going to show you some of the support we've done for branching and merging. And let me just clean up a couple of my virtual machines quickly for you. So let's say that this is my website that I'm working on, and this is in production right now. And if I look at this website, I look down here at the bottom, and we just noticed that none of these links actually work in production at the very bottom here. And so, the marketing team's getting very frustrated with me, and they say, hey, we need to fix these things that are happening in production. And I say, that's great, but I've got a job to do. I'm working on the current iteration of things that you've asked me to do, and it'll be next Friday by the time we push to production again. And they say, of course, that's not good enough. Our customers can't actually use the website right now, and blah, blah, blah. So we say, all right, fine. What can we do? Well, we can fast track a change into production. And so what that means, of course, is that we're going to go out to the code that's currently deployed on my website, and we're going to make a change to that website directly within that branch, and we're going to redeploy that. Now, that's great if we make that change to production. The challenge with that, of course, is that if we make that change to production and I push a new branch out next Friday, which represents what's currently in development with my iteration 2, then there's a chance that I could actually reverse that change, and now my website's going to have the same problem again. And so I'm going to take you through a quick scenario here where we'll make a change directly to the production branch. Actually, what we'll do is we'll make it to the iteration branch first, and then we'll branch that change and push it over to the production website so that that change can be deployed without having to wait for the rest of the work that's happening in the system. Okay, so that's a pretty simple scenario. I'm sure you could imagine other places where this might be helpful for you and where you've had to do something similar to that. Here you can see that once Visual Studio comes back, there we go. There's my production branch. And so what we'll do is actually there's a couple different ways we could do this, but let me go ahead and make the change to iteration 2. And I happen to know that that file exists within this template.master. And template.master is what defines the footer at the bottom of that page. So I'll just come down to this footer, and because this is something I need to fix quickly, I'll just comment all of this out. And after I comment that out, that's the change that I want to push out to production. So we'll go ahead and save that. And if you use Team Foundation Server, then you're familiar with pending changes. Making a change to fix broken links. We'll need to fast track this to production. And so we've gone ahead and checked that into the branch. Now, how do I actually fast track that to production? Well, today, if I'm a developer and my job is to focus on iteration 2, all I know is that I wake up every day and I come into the source control branch and I start working in iteration 2. The challenge with that is I don't really know how the source control branches work throughout my system without maybe talking to a lead developer or somebody who's been around forever. I'm sure if you think about your own branches within your own source control repositories, some of them can be quite unwieldy. And if the person who understands all of that gets hit by a bus or decides to quit, then you'll probably be in a lot of trouble because trying to reverse engineer that can be quite difficult. At least that's true back within Microsoft and some of the teams I've worked on. And so to understand that, we've introduced branching and merging visualizations. So what I can do is I can start by saying view hierarchy to help understand how one branch relates to one another. And so here you can see that iteration 2 is a child branch that was branched off of main. So that becomes helpful. And if I take a look at the full hierarchy, you can see that this is what I'm looking at. So if I want to take a change that I just made in iteration 2 and move that over into production, then I know that I need to merge it first through main and then move it back into production. Very simple branching strategy. We're not going to be talking about any really complex branching strategies here. We've got some white papers out on Codeplex if you're interested in understanding some of the ways that we branch and merge within Microsoft. But today I just want to show you some of the tools that can help you regardless of the branching and merging strategy that you might be using. And so if I come back into source control and say, all right, let's look at history for that check-in that I just made. I know that that check-in was, let's see, where is it? Oh, I made it in production, didn't I? Thank you. There we go. So that's the change that I made. And let's say that I want to move that from production now back into iteration 2. This really works both ways. What I can do is I can right-click and now say Track Change Set. And when I track change set, this will ask me which branches I'm interested in looking at. And so I know that I want to see the relationship between iteration 2 and the production 1 branch. And so I'll say visualize that. And then quickly I can see that this particular change set has been checked into the production 1 branch. So that's great. Now I know that I need to move that from production 1 into main. And so what I can do is just drag and drop that onto main. And it's automatically going to open up the branching and merging wizard for me. So I'll say, go ahead and merge this. And now this is going to pin that change. So merging into main, so I can get this fast-tracked change back into iteration 2. Check that in. Now you do need to rerun the visualization now to see the updates. And now you can see it's checked into main. We'll just do the same thing here. And now we'll go ahead and check that in. And so now very quickly, I have confidence that that change was merged into both of those branches, and I'm not going to be surprised next Friday when I go in and check something back in and it breaks a fix that we've already made. This is also useful, by the way, if you're trying to figure out, if a customer received a particular bug fix in their given branch. And so if you know that the last build that you gave for a customer came out of their private branch on Thursday, but that didn't actually get merged in time for Thursday's build, then you may need to get them an updated build. And so one of the things you can do is you can actually look at timelines, and you can see right away the times that changes were actually introduced and merged from one branch to another. And so here I can see just by clicking over the exact time that it was moved over. So those are the types of questions you can answer. The other thing that this scales to is if you have bug fixes that may be represented by multiple change sets. So I made multiple changes in order to implement this requirement or to fix this bug. As long as I track by that given work item, it would actually show me all of the different change sets that need to move over as a result of trying to merge that change forward. Okay? So while we're in here, let me also show you another capability that we introduced in 2010, and that is the architecture tools that we have. So one of the things that I can do with the architecture tools, and let me just reload my solution. One of the things that I can do is start to generate dependency graphs, which help me understand the existing code that I'm looking at. Maybe this is code base that I inherited. Maybe I'm new to a project. Maybe there's not really great documentation out there for the existing project that I'm looking at. And so we wanted to give you some ways to quickly reverse engineer the existing code that's out there in your solution and help to understand how changes you make in one part of the code may impact changes to another part of the code. And so I can actually generate dependency graphs based on assembly, by namespace, by class, or I can generate custom dependency graphs as well. Let's go ahead and just generate a quick one based on assemblies. And this is going to go out and look at the MSIL and reverse engineer a dependency graph for me. Now in Feature Pack 1, we also added support for native code as well. So if you're a native code developer, write C++, go get Feature Pack 1 from your MSDN subscription, and then you can start working with native code here really nicely. And so here I have a quick diagram that shows me at a glance what my project looks like. And so here you can see that I have a few different assemblies out here, tailspin.model, I have tailspin.simple SQL repository, and then I have these red blocks or these pink blocks which represent external DLLs that I don't have access to the source code for. So by default, we go ahead and group those under their own category. So if I expand externals here, for example, I can see that these are all the .NET Framework classes that I'm using within my project. Pretty much every project you build on the .NET Framework is going to use MS Core Lib, so I don't need to represent that on my dependency graph here, so I'll go ahead and delete it. Of course, I'm not deleting that from my system. That would be bad. There's multiple versions of this because we're actually using .NET Framework 3.5 and 3.0 here, so I can delete that. System.dll, I don't need that on every diagram. And so really what you can see here is I can clean up this diagram and use it to logically give me a better sense of what it is that I'm looking at. And there I've got a cleaner diagram. And one of the things that I may want to be interested in is how changes may be impacted if I was going to migrate this to the next version of the .NET Framework. And so one of the things I might want to do is get a better look at how those external libraries are represented within my project. And so I can just remove this group, and now that's going to take all those DLLs and actually, that's not what I wanted to do. This was working just 10 minutes ago. I should be able to say remove group, and what it does is it takes all those libraries and then spreads that across my project. For some reason, that's not working here. I wonder if I... Oh, there we go. So I guess you have to expand it first. Interesting. That looks like a bug to me. All right. So now I've got all those external libraries represented, but I have no way of differentiating anymore between which ones are external and which ones are ones within my project. So one of the things I can do is say add a node property to say is external. And so then we can start customizing this diagram, and we can set the background color for the external ones to red. And now I've quickly got a diagram which easily shows me the relationship between all the different assemblies within my project and then those that are in the .NET Framework. And so there's a lot of other stuff that you can do in here. You can say analyze and say find circular references, any Hobbs unreferenced nodes. So maybe we've got the opportunity to go back and refactor and clean up stale code within my project. We give you lots of tools to help you do that. Another thing that we did within this release is we represented we added the ability for you to model UML within here as well. So a lot of people have asked us to support UML for a long time within the tool set, and now we support 5 different types of UML diagrams within here. So there you have a use case diagram, class diagram, activity diagram. I can also point to existing code and generate sequence diagrams. So how often have you taken a look at somebody else's code, or even code that you wrote 6 months ago, which may as well be somebody else's code, right? And you look at it and you try and figure out what this code does, and so you start stepping into and you press F5 and you set a breakpoint, you try and figure out the flow of how this code goes from one piece of code to another and all the different callbacks. Well, now you can just generate a sequence diagram that actually shows you multiple levels based on how this code interacts, and then you can save that, and that can be an ongoing artifact within your project. The other thing you can do is make changes to that so that if you're proposing, hey, I think that this code should be changed so that we're actually calling into this library over here instead of doing all of this work internally within our own class, then you can propose that change and save that to a TFS work item so that the person working on that understands the change that you're asking them to make. And then finally, in addition to the UML diagrams that we support, we also support a layer diagram as well. And this layer diagram is something we've all worked with. We've drawn out the architecture for our application on the whiteboard, and we've said, all right, we're going to build a model view controller application, and so we've got model view controller, and one can talk to the other, but model and controller can't talk to one another, or whatever the dependency maps are that you have in your given architecture. And that's all fine and good to actually draw that out on the whiteboard and say whether or not, this is how we want to develop the architecture. But then developers go off to their cubicles and they start writing some code. And pretty soon what we thought we were modeling doesn't always map back to what we actually get within our source control repository, right? We're guilty of that as well. And so one of the things that we wanted to do with this layer diagram is actually tie that layer diagram back to your source code so that you can start to perform some interesting validations and say, does the code that I have over here actually resemble the layer diagram that we've architected this solution to look like? And so here to generate this layer diagram, I first started by dragging some shapes onto the surface, but then I also went one step further and took the classes and the individual methods even within my source control, and I started associating them with this diagram. So here you can see that controllers, for example, consists of these 4 classes. And so now what I can do is I can right-click and I can say validate this architecture against my existing subsystem. And this is going to come back and tell me whether or not any of my existing code is taking dependencies on classes that they're not allowed to, or if those dependencies are going in the wrong direction. And it's going to quickly tell me whether or not I've got the architecture correct. And so here you can see that if I expand my errors, it's going to tell me that we have some invalid dependencies. I'm not going to get into the specific dependencies in here. It's not really important. But basically, what this is telling us is maybe something from model down here is calling into controllers as opposed to controllers calling into model. Because you can see here, I have this one-way relationship represented by that arrow, but I'm not really allowed to call into controllers. So that's one thing that you can do. You can also tie this into your build server as well, so that if somebody checks in code which violates this layer diagram, then it can actually generate a warning or an error and say, hey, somebody just checked in some code, and we might consider this a build break. And in fact, we have a new gated check-in system with Team Foundation Server 2010, where we can actually build your changes first and then validate those either by running unit tests, static analysis, or a layer diagram validation. And if anything that you decide is a threshold to fail that build actually is triggered, then we can actually kick that back to the developer, and it never gets checked into source control. So that's really nice because you can actually get the system where you're never breaking the build again. We actually don't let you break the build, and so you never have to buy pizza and beer for the rest of your team, as a lot of teams do. And so the other thing I can do here is I can actually do the reverse, which is to say generate the dependencies that would make this layer diagram resemble what's in my code. And then for those of you in the front row, you may have noticed that we actually added some additional arrows up here to actually represent what's currently within my code. So that's another way I can go about it, is I can get my layer diagram into a good enough state and then generate those dependencies and see what that looks like. So that's our architecture tooling. So I don't know if you recognize this gentleman. I like to call him the grandfather of Team Foundation Server. Of course, he died long before Team Foundation Server came out. But if you think about what he stood for, this is Lord Kelvin. And Lord Kelvin is credited with inventing the Kelvin scale in terms of measuring temperature. But he also has this quote that's often attributed to him as well, which is that you can't measure something, or rather you can't manage something until you can measure it. And when you start looking at very complex systems like building software, it can be very difficult to know if the changes you're making as you go out and assign more resources to a project, or assign more testing effort, or extend the iteration length so that you can try to get more work into the existing system. What do all the changes that you make as you're managing your project have on the end result of what you're actually delivering? And so that's why we built Team Foundation Server from the ground up, as I mentioned, to be this multiple subsystems linked together that we can then start generating some really interesting reports off of. And so this first report is what I like to call the Steven Sinofsky report. So you may know Steven Sinofsky. He's the guy who's in charge of the Windows division at Microsoft. And he just presented at Mix, and he's really doing a phenomenal job around delivering great versions of Windows. And Windows 7 was actually built, a lot of people don't know this, but Windows 7 was actually project managed using Team Foundation Server 2010. And so they used a very early version of Team Foundation Server, and they used that to start storing all of the features that they were going to deliver in that release, and then start decomposing those features into what it would take to implement those features. And so what that means is, as Steven Sinofsky, I can take a look at this report, and I can look at one of my pet features here. So for example, maybe I care about, this isn't Windows, of course, but as a customer, I want to track my order history. And I take a look at that and I say, okay, great. I know that that's 79% done, right? And what does that mean? That means that developers are saying that they've implemented 79% of the code, or they've done 79% of the hours of work that they've said that they were originally going to sign up for to implement this. And generally I might be pleased with that until I look at the next perspective of this, which is pulling in our test data, and that says that I actually don't have any tests written against this particular feature. And that doesn't give me a high degree of confidence that even when we get to 100%, that it's going to be done correctly and it's going to be done, as they say. And so by looking at a report like this, you can quickly look across all the different features or scenarios that you're trying to enable within your release, and you can understand those multiple perspectives about how much of the work is being done, how is the test plan progressing. In last night's build, for example, how many of those tests were passing, how many of those tests have been run. Here's another perspective that you get when you light up the SharePoint integration with Team Foundation Server. We actually put all of these reports right on your SharePoint dashboard. And so here you can see how my bugs are moving through the system. On the left-hand side, you can see these are different perspectives. And so I have a burn down perspective, quality perspective. And so here you're looking at the bug perspective. The next report I have here shows me how much of my code is changing day to day. And so in an ideal world, your code would actually start to stabilize as you get towards the end of the release. But I'm sure we've all been in situations where we get in on Monday and we realize the developers have been working hard over the weekend, and that's great most of the time, except you don't want to have a lot of changes and a lot of check-ins happening on the weekend right before you're getting ready to hand off a build to your customer. And so at Microsoft, we go through these ship room exercises. I'm sure you probably do something similar, where in the beginning of a milestone, everyone's allowed to work on their own feature branch and check in code and implement features. And then we kind of let everyone know what we're working on, and we show our progress. And then once we get a few months out to a beta, then we go into what's called tell mode. And tell mode means that you're showing up to a ship room that has representatives from all the different teams, and you're telling them what it is that you're changing. So if you are the .NET Framework team, a lot of people may be interested to know that you're making changes to some subclass that they may use within their project. So you tell them, hey, we're making changes to the way that system.string is represented, so you need to go test your code against the builds we're producing. And then once we get maybe a month before a release, then we shift into what's called ask mode. And as the name implies, ask mode means that you're going into ship room and you're saying, we would like to make this change. Here is the reason we're making this change, because it's a security hole, or because we have 20 customers from our TAP program that are telling us this is really important to change, and they won't use it unless we make this change. And sometimes you get into these situations where the people in the room say, all right, show us, open up Visual Studio, show us the lines of code that you want to change. And so it's kind of interesting. You get these vice presidents doing these code reviews within these meetings, so that can be kind of fun. But the idea is that you're constantly stabilizing on that amount of code that you're checking in. And so here, this is just a quick report that shows you and gives you some potential warning signs to say, hey, are we actually decreasing the amount of code that we're changing day by day as we get closer to that release? This is an interesting report because on the one hand, you may look at the burn down up here, this task burn down, and you say, all right, that looks groovy. We're on track to actually ship by Friday, and I can tell that we're continuing to make steady progress against the remaining hours that we decided, and we're hitting that trend line. That's great. Tell our customer that we're going to have a good build for them. But then you look at the other perspective of this, and if you look down at this user story progress, you can actually see that we're not closing out any user stories. And that tells me that we're doing a little bit of work over here, and we're doing a little bit of work over here, and we're doing a little bit of work over there, but we're not actually spending the time to get an entire feature or set of features done so that those can be thoroughly tested by the test team, and we can have confidence that these features are going to be working well together. And so this may be a sign that I need to have my developers really focus on nailing one or two of those features so that we don't get to Thursday before all the features or any of the features are actually working, and then we've got to hand off something to the customer on Friday. So just another way of showing how these multi-dimensional, multi-perspective views can show your project in different light. And if you use Team Foundation Server in the previous releases, you might know that we implemented web access as a client as well. So, if you don't always have Visual Studio installed on your client, or maybe you're a project manager or a business stakeholder and you don't need Visual Studio, you can access everything through a web access client. We also took a lot of the functionality from that, and we created SharePoint web parts as well. So that's what you see here are SharePoint web parts that actually represent the bugs or the burn down reports or whatever you want. You can actually build custom portals and then hand that off to the vice president, for example, and say, hey, here's a custom portal that shows you exactly the reports and the bugs that you care about, that you keep asking about. And here's some more as well. I'm not going to bore you with going through all of these. Now let me jump into a demo that shows you how project management works within Team Foundation Server 2010. So as I mentioned, we have a lot of support for what are called work items. And if you don't use Team Foundation Server today, a work item can be anything that represents the state and has a workflow and a user assignment. And so that could be a bug. A bug opens in an active state. It moves to a resolved state after the developer's checked it in, and then it moves to a closed state after the developer or the tester has validated that it's actually closed out. Now, you can change these workflows. You can customize the forms. You can create your own type of work item artifacts. But we give you a lot of work item artifacts out of the box in what are called process templates. And so we have an MSF Agile process template, which is really designed for Agile teams, an MSF CMMI process template, which is designed for when you need to have more validation and more sign-off, such as if you're working for a government agency or if you're building rocket ships, for example. And then the other process template that we shipped later on, a few months after we shipped 2010, is a dedicated Scrum process template. So we found that over 85% of teams that we talked to that were practicing Agile are actually practicing some variant of Scrum. And so we came out with a Scrum process template that's using the same Scrum methodology that you'll use if you go out and pick up a book by Ken Schwaber and read about what a sprint is and what a product backlog item is and a user story and all this different terminology. But for this project, I'm actually using our MSF Agile process template, and that ships with a few workbooks that make it easy for me to manage my backlog and then decompose work as well. So if I look at this team query here, I can take a look at my product backlog. And my product backlog shows me right within Visual Studio all the different work that's currently on my backlog and scheduled or not scheduled for a given iteration. So I can scroll over and I can see whether or not it's scheduled for a given iteration. And I can manage this within Visual Studio if I want to, but that's not always the best experience. What we do instead is we actually give you some Excel-bound workbooks that you can use to open this up within Excel. You might want to use this within your weekly team planning meeting or your daily stand-ups to actually take a look at all of the work that's in Team Foundation Server, manage that, make bulk edits to it within Excel, and then from there you can, once you get it into the state you want it, you can publish that back to Team Foundation Server. So here I have the same product backlog that I was showing within Visual Studio. So this is just a list of user stories, but you can use whatever terminology you want. Maybe these are requirements or features, something that you're going to build within your product. And you can see that I've already got some work that's been done in iteration 1. I've got some work that I'm currently working on in iteration 2. And we're wrapping up iteration 2, so I really want to plan what's happening in iteration 3. Well, if I come over to this iterations tab, I can come down and define when iteration 3 is going to be. And so let's say that that's going to be a 1-week iteration that happens next week. So that'll be 5.2 to 5.6. And I actually have 3 team members that are going to be working on that with me. So if I come back to my backlog, I can take some of this work in the priority order that it's already in and start popping that onto iteration 3. And then as I go through here, if I take a look at my iterations again, we give you a chart that shows, compared to the other iterations, how much work have we taken on. And because I actually have a team size of 3, the last time I did that was on iteration 2, and that was also a 5-day iteration. I think that I can pretty much approximate the amount of capacity which we took on in iteration 2. So I'll just keep adding work to my backlog, or to iteration 3 from my backlog. And here you can see I took on a user story that was a little bit too big. So what I can do is pop that back onto my backlog, and I can either call it a day there, or I can go look for another user story I might be able to fit into this sprint. And I like to be aggressive here, so let's take this 3 user story point work item, and we'll pop that back onto iteration 3. And now I feel pretty good about that. And so now that I've groomed my backlog, I can come back to the team tab here and say publish, and that's going to push that data back to Team Foundation Server. Now that it's in Team Foundation Server, if I refresh it here, you can see that I now have work which is assigned to iteration 3. Now, that's good. I have kind of a broad idea that I think that this work is something I'll be able to achieve in the next iteration. But the one thing I haven't done is I haven't actually broken down that work yet to say, okay, what do these user stories really consist of? So let's do that now. And to do that, I'll use another workbook that we have, which is the iteration backlog. So I'll open that up for iteration 3. Thinking about it. And when you open these up, you always want to click refresh as the first thing you do, because that's going to pull in the latest data from Team Foundation Server. And here you can see that I have some user stories which are represented in here. We added work item hierarchy in this release, so we actually have proper relationships between user stories and their child tasks. You can also model dependent tasks. You can say this is a predecessor, this is a successor. There's lots of different relationships you can manage, tested by. But here I have the list of user stories, and I've already broken down a few of these. So I've decomposed this user story into 3 child tasks, this one into 2 child tasks. Since I just added this new user story to iteration 3, I haven't broken it down yet. So let's go ahead and do that. I think that's going to consist of 3 different child user stories. And I'll just do some copy and paste magic to save us some time. So I can just go ahead and paste these tasks in here. And so maybe for this user story, I want to create a stored procedure. I want to design the password reset UI and implement the password reset UI. And I've taken a guess at some people on my team who might be able to do this work. I've sized it by assigning remaining work to it. And then I can just assign the rest of these to iteration 3. So now, just like I did in the product backlog workbook, I can come back and I can assign dates to this. In the next release, we're actually going to make dates first-class citizens so that you assign them once within Team Foundation Server, and they automatically populate throughout these workbooks. And then if I come to capacity, I can tell it who on my team is working on this particular sprint and how much time are they on task. So this isn't time updating Facebook and updating Twitter. This is actually time that they're working on code. And so here quickly I can see that from a team capacity perspective, we're looking pretty good. We still have plenty of capacity. In fact, we could probably take on more work and go back to the backlog if we thought that we wanted to do some more stuff here. But I'm a little bit worried about the individual capacity. You can take a look at April here, and she's our dev lead, so we want to make sure that she has time to help the people on her team, but she currently has a lot of work on her plate as it is. And as a matter of fact, she came to me and says, you know what, I've been working so hard, I need to take a vacation next week. So you can model this as an interruption for her. So she's on a 2-day vacation. And as it turns out, Monday is actually a company retreat. So nobody on my team is going to get anything done on Monday. And now if we take a look at that capacity, you can see it actually tells a very different story. So now we're no longer confident that we'll be able to do this work because April is so overloaded since she's trying to take some time out of the office. And so now if I come back to my iteration backlog, we can start looking for volunteers to take some of this work. So, this implementing the web front end for this user story, that's a pretty big task. And turns out that we'll get Doris to actually work on that one. And so if we come back to capacity, we can see she's still a little bit overloaded. In fact, I don't like Doris having that because it's a lot of work. So let's, instead of assigning it to Doris, we'll assign that to Abu. And instead, we'll take another user story here, maybe this one, or another task rather, and we'll assign that to Doris. And so now if I look at my capacity, that's actually much more realistic. I'm pretty confident that my team can deliver on this despite the interruptions that we have. And so now if I come back to my backlog, I can take this and publish it. And now, of course, as you would expect, that shows up if I look at iteration 3. So there's all my work within iteration 3. And the other nice thing here that we've done in Visual Studio is we even make it easy for you to work with the work item hierarchy without dropping to Excel. So one of the things I can do here is I can take this and drag and drop it to another, and that automatically creates a child for me. I can indent this. It makes it really easy for you to just add new work and decompose right within Visual Studio if you don't want to use Excel or if you don't have that installed. Now, those are bold because I haven't actually persisted them to Team Foundation Server yet, so I'm not going to accidentally make a change. What I can do is I can actually just refresh this, don't save those changes, and now I'm back to what I was looking at. Now, a lot of people ask if they can use this with project as well, because a lot of teams like to use project to actually create some detailed day-by-day plans that says, who's going to do what work on Monday, who's going to do what on Tuesday. And so now what I can do is I can open up this same plan within Microsoft Project. And when we import this work, I can do things like add some dependencies in here. So, maybe before I implement the web front end, it would be nice to actually design that web front end. So that seems like this particular task has a child dependency on being able, actually that's the wrong one, on being able to design the web front end. So if you look at that dependency I've modeled, now that's going to be represented. And in the previous releases of Team Foundation Server, since we didn't have this hierarchical work item tracking, you actually had to store your project plan off to the side in another project plan and maintain that kind of separately from Team Foundation Server. But because we have all of these relationships modeled right within TFS now, I can just publish that to Team Foundation Server. And now if I take a look at that particular work item within TFS, and we open that, we take a look at the implementation details, you can see here that I have that predecessor modeled as well. So that's really nice for working with Project. If you use Project Server within your organization, we also recently released another feature pack for Project Server and Team Foundation Server integration. One of the nice things about that is you can actually run your projects on your development team using an agile methodology or whatever methodology best suits you. But if you have then a requirement to report back to the business in a bit more of a formal fashion, maybe a PMO office, then you can decide which work out of Team Foundation Server you actually want to synchronize back with the project management office, and then they can look across the enterprise and they can automatically see the work that you're doing surface across their project plans. And you don't have to do this double entry of having someone enter work in TFS and then go over and update and report back to the business what you're working on. So it's a really nice way of getting that going. And I actually just shipped a virtual machine last week if you want to see that in action. It takes you through a few different hands-on lab scenarios so you can get a feel for how that works. So we're just about done here. I just wanted to conclude by talking a little bit about the testing enhancements that we've made in this release as well. And the presentation after this is going to be focused on lab management, and it will also show you some of the manual testing stories that we have within a demo fashion. But I quickly wanted to whet your appetite and position a little bit of what we did in this release to support software testing as well. So one of my hobbies is I'm a rock climber. I like to go out and climb glaciers and climb rocks. And so as part of that, when it's raining like it is today, I would go to the gym and I would spend a lot of time actually working on conditioning and working on my skills and working on trying to learn first aid and become more familiar with my rock climbing equipment. Because by the time you get actually out onto the rock or out into a real world scenario, the cost of failure goes up dramatically. Right? I mean, if I hurt myself in the gym, it's no big deal. There's 40 people around and there's a hospital down the street. But if I'm out on a glacier like I was here, and I don't know if you can quite appreciate the scale here, but I'm basically standing on top of this really narrow ridge, and both directions goes hundreds of feet down before you actually, find some other ground. And by that time, it doesn't matter. That's when the cost of failure is really, really high, right? You want to really make sure that you've trained well with your team, that you understand how to use your equipment, you understand all the first aid that you've got. And I don't know if you can tell, but behind me, there's actually a hailstorm that was moving in on us. So about 20 minutes after this picture was taken, we got hit by a hailstorm. And at that point, you're really glad that you brought all the gear that you did because it was a long day getting back down the mountain. And so software is the same way, right? If we find a bug while we're developing software and we can get some tools within Visual Studio, either the syntax checking or some static analysis or unit tests that we've written to tell us that, hey, you just broke a piece of code, it's not a problem. We know the change we just made. We know the files that we had open that we were working on. It may take us, 10 or 15 minutes to figure out how to get it right, but we have a pretty good sense of where that bug is. The cost of the business may be 30 minutes if we can discover it there and fix it right away. But by the time you actually ship that code out to the customer and they discover a bug, it's bad enough that you now have to go back and find the person who wrote it or try to figure out how to fix it so you can get them a new build of the software. But you may also have a situation where you just cost them a business deal, or you just caused, sometimes I show these examples of submarines that were dead in the water because of software bugs, or any number of things that could cause somebody to die as a result of software that's in a medical equipment. So it can be really, a very high cost scenario. And so whenever possible, what we want to try to do is we want to drive that quality upstream. We want to give the developers the tools that they need in order to fix these problems as they're developing them. And if not, then we at least want to focus on those test organizations to give them the tools to fix them before they go out to the customers. And so, we've been doing a lot to help developers, and we looked at test organizations and said, how can we help them as well? And we looked at a typical test organization across the industry, and on the far left-hand side, you have manual testing. And so these are people that wake up every day and they maybe have a set of Word documents that they follow that tell them, okay, you need to open up last night's build, you need to click here, click there. It's very laborious manual testing. Oftentimes they also do exploratory testing as well, where they try to go off the beaten path from those scripts. But the idea is that there's a lot of really laborious effort going into making these testing changes. And then at the far right end of the spectrum are some of the tools that I showed yesterday in terms of writing automated tests. And so these are people who are writing code which tests other code. Maybe it's testing for scalability. What happens when we have 10,000 users hit our website? Or maybe it's making sure that we're writing good unit tests, or making sure that we write coded UI tests like I showed yesterday. And the challenge is that at least prior to 2010, the majority of the manual testing work, let me back up. The majority of testing work that would take place across most of these organizations was still manual testing. About 70% of the effort that goes into software testing across the industry is manual and labor intensive. And I think it's going to continue to be that way because oftentimes test automation is too expensive or too fragile for a given set of software tests. So you're still going to need those manual testers there. The problem is that the majority of the industry, if you take a look at other industry vendors and even open source projects, we have great support for doing test automation. There's 15 different ways of writing unit tests. There's 10 different ways of writing functional UI tests. But the majority of the work that's been done over the last 10 years has kind of left those manual testers to use Microsoft Word and Microsoft Excel to manage all of their test cases. And so for this release, we really wanted to target those manual testers. The other thing that we wanted to address is what happens when a bug is found. Think about the last time the last time you as a developer had a tester come to you with a bug. and you take a look at maybe this one-line description, and this description says, something happens when I click this button, and then it does something else which I don't expect it to do. And you run it on your machine, and you say, you know what? It works on my machine, right? This happens all the time. And the reality is that the tester probably did find a legitimate bug. They probably went back to their test environment and they can reproduce this bug, but their test environment is different than your machine, right? And so you start asking them questions and you say, well, you're running, 64-bit or 32-bit, because you know that the build I gave you is only 64-bit. Yeah, I'm running 64-bit. Are you running Internet Explorer 8? Because we don't support Internet Explorer 6. Yeah, I'm running Internet Explorer 8, and I've got another machine. This also repros on 9 and Firefox as well. And so you have this ping pong game that goes back and forth between the developers and the testers. And that causes a lot of waste in the system. And at the end of the day, you're not only wasting their time, but oftentimes these bugs actually don't get fixed. And so, again, I'm not going to show you a demo here because you're going to see that in future sessions today. But what have we done to actually address these three challenges? Well, number one, I've told you that we're investing in manual testers. We have a first-class tool that integrates with Team Foundation Server called Microsoft Test Manager. Microsoft Test Manager gives me a platform to manage my test cases, to author those test cases, and then as I'm running those test cases, we can actually automatically capture rich information about those test runs, so that in the future, you can take a bug that was found by a tester, and as a developer, you open that up within Visual Studio, and you don't just get this one-line description that says, hey, I clicked this and this other thing didn't work right. You can actually see a video recording that shows you exactly what the tester was doing. You can get an IntelliTrace file, which you'll see later today, which shows you step-by-step what was happening within the stack trace as you were going through and executing the application. You can get system information that says the tester was running on a machine that had 64-bit, 4 gigs of RAM, and here's the specific build that they were running. And so maybe you can tell, oh, okay, that's the problem because they're running last night's build, and that's why I can't reproduce it on my machine. And so the idea here is that we really want to give you a rich payload, this actionable data that you can use to understand the bug, and then, of course, to fix that so it never makes its way to your customer's environment. So really quickly, I showed this a little bit yesterday, but the way that we enable this test architecture within 2010, it's really scalable, the way that you can start taking advantage of some of these tests, and you're going to see that in the next session, so I don't want to steal too much thunder here, but basically you can even set this up with virtual machines so that you can take advantage of what we call lab management in 2010, and you can take advantage of a build, deploy, test lifecycle where every night maybe, or even multiple times a day, you're automatically building your software, you're spinning up one or more virtual environments, which may consist of different flavors of operating system or different flavors of database software that you need to test against. And then you can automatically deploy that code out into those virtual environments and then take all of your automated tests and run those in each one of the virtual environments. And then your testers automatically have the machines configured the way that they need them to run all of their manual tests. And the other nice thing about this is that you can take snapshots along the way. So if you want to go back at any point in time and say, oh, show me Thursday night's build, you don't have to go find a machine and install Thursday night's build and go through that 3-hour process to get everything up and running. You can just save that off to the library somewhere, and then if you want to take a look at Thursday night's build, you've got a virtual machine that can show you that. The other thing is that if you find a bug within that environment, either during an automated test run or during a manual test run, you can save a snapshot, and then you can attach a pointer to that snapshot to the bug. So now I not only have the video recording that shows me what the tester was doing and the IntelliTrace information and all this really rich information about what was happening, but I also get a link back to an environment that I can open up and see exactly how this is manifesting itself. So that's all enabled for you. And in fact, if you own Team Foundation Server 2010, you actually already own what you need in order to start taking advantage of lab management. At that point, you just need either the manual testing product, Microsoft Test Manager, or as a developer, you need Visual Studio Ultimate, and that will give you everything you need to connect back to these lab-managed environments. So, I didn't mean to click on that. So that's all that I had. Please take the time to fill out the evaluation form. I will stick around after this session if people have some questions and they want to come up and talk. It's been really great to be back at Tech Days again this year. I hope you'll invite me back next year. Thank you.